Okay, on the next page, we begin our discussion of energy. Okay, so here we use a little bit of algebraic derivation to figure out a formula for work that includes energy. So we said that since net force equals ma, we can use that relationship in our formula for work, since we know that work equals Fd. So if we substitute, we get work equals mad. Now this next step says, let's use this kinematic equation, which you guys should recognize, and let's replace delta x with d. And then in this next step, let's solve the equation for AD. So we get VF squared minus VI squared divided by 2 equals AD. Then using this definition for AD, substitute it into the equation above for W equals FD. So we're taking this equation here for AD and plugging it in there. Sorry, it does not include mass. Okay, so then work equals M times AD, which is VF squared minus VI squared divided by 2. Simplify into one final term and one initial term. So what that means is that usually we combine things to simplify, but this time we're saying let's distribute the M and the 1/2, and let's expand this term so that we have an expression that considers a final situation and an initial. So then we get work equals 1/2 mvf squared minus 1/2 mvi squared. Now here I tell you guys that the formula for kinetic energy is 1/2 mv squared, or Ke equals 1/2 mv squared. And if that's the case, then when we compare that to the equation that we just derived algebraically, we see that work must be equal to Ke final 1/2 mvf squared minus Ke initial 1/2 mvi squared. And anytime we have a final term minus an initial term, we know that that's equal to delta of something. So work is equal to delta Ke. So here in these problems, you can check your answers later on the solution sheet. And let's move on to the work and energy problem. So here we have a box of mass 50 kilogram pulled by a 200 Newton horizontal force. Okay, so here is our box on a horizontal surface that has friction. It's being pulled by a horizontal force, and this is U. Normal force on the box by the surface, weight force on the box by the earth. And remember, this is not the free body diagram. This is me annotating my picture. So the free body diagram shouldn't have anything other than forces on it. Okay, and the question says, the work done by the person pulling the rope. The coefficient for kinetic friction is 0.3 and the box has moved 5 meters. So this distance is 5 meters and this is a 50 kilogram box. Okay, so the work by you is really the work done by tension because you are pulling the rope. So then work equals F cosine theta d. Tension is 200 newtons, cosine 0 times 5 meters equals work. Cosine of 0 is just 1, so this is going to be 1,000 joules. Okay, and it's positive because the force that we are talking about, tension, is in the direction of motion. The box is moving to the right and tension is also to the right. Therefore, work done by tension is positive. The second question says, what's the work done by the kinetic frictional force? So we have work done by kinetic friction is going to be equal to Fk, cosine of 180 degrees, times d. And recall that Fk is mu k times the normal force. The distance was 5 meters. So we're really solving for the normal force here, so let's look in the y direction again. This time there is no vertical component of an applied force, so all we have in the y direction is the normal force on the box by the surface and the weight force on the box by the earth, and that's going to equal 0 since the box is not accelerating in the y direction. Recall that weight is equal to mg, so we have normal force on the box by the surface equal to weight on the box by the earth, which is equal to mg. So 50 kilograms times 10 meters per second squared, or 500 newtons, is the normal. So then the work done by the frictional force is equal to 0.3, which was mu k, times 500 newtons, times cosine of 180, which is -1, times 5 meters. Okay, so let's take a second and plug that into our calculator. So 0.3 times 500 times cosine of 180. -750 joules. Now question C said, what is the work done by the net force? So a couple of ways you can do this. The first is you can say, well, the work done by the force going to the right, the work done by tension was equal to 1,000. The work done by friction was equal to -750 joules. So then therefore, the net work is equal to 1,000 joules minus 750 joules. Okay, another way you could do this was you could find what the net force is. So you can say in the x direction, I have 200 newtons to the right. I have 150 newtons to the left from friction. This is Fk. This is tension. So the net force is going to equal 50 newtons. And then this becomes Fa in our work equation. I know that the net force points to the right, so I know that theta is 0, or the work done by the net force is equal to 50 newtons to the right times cosine of 0 times 5 meters. So either way, I arrive at the same answer, 250 joules.